For this day competency, the learner is able to represent real-life situations using functions, including piecewise function, and solve problems involving function. But today we will just discuss functions, how to represent functions rather. Definition of terms we have here. Before we define functions, we'll define first a relation. A relation is a set of ordered pairs x and y. A relation is a rule that relates values from a set of values called the domain or the input to a second set of values called the range or the output. A function is a set of ordered pairs x, y such that no two ordered pairs have the same x value but different y values. So, if we talk about a function, it should be a relation provided that no two ordered pairs have the same x values but different y values. A function also is a relation where each element in the domain is related to only one value in the range by some rule. Function and relations as a table of values rather. Example number 1. Which of the following sets of ordered pairs are functions? We have letter A, an ordered pair F, a set F with an ordered pair 1, 2, 2, 2, 3, 5, and 4, 5. Is this a function or not? This is a function since we have here, this is x again, this is x value, and this are y value. So again, this is x value, this is y value. So for every x, so we have x here, we have 1, 2, 3, and 4. The corresponding y value for 1 is 2, for 2 is 2, for 3 is 5, and for 4 is 5. So therefore, all x's, which are 1, 2, and 1, 2, 3, and 4, has a unique value of y. So therefore, this is a function. Next, we have a set G contain the ordered pairs 1, 3, 1, 4, 2, 5, 2, 6, 3, 7. This is not a function since for every x we have this one. For every x, okay, for x, if x is equals to 1, which is this one, their corresponding y value we have 3 and 4. Therefore, for every input or for every x, the corresponding value y is 3 and 4. So that is not unique. So therefore, this is not a function. Then letter C, we have H contains the ordered pair 1, 3, 2, 6, 3, 9, and so on and so forth until with a formula rather of n and n 3 times n. So, for every x, for every 1, the corresponding value of y is 3. Okay? Or for every n, the corresponding value of y is 3. So therefore, this is a functions. So next, we have which of the following mapping diagrams represents function. So we have this one, the F diagram, the Y diagram, F diagram, the G diagram, and the H diagram. So for F diagram, obviously for every x value, we have this one, that for every x value, they have corresponded one y value. So therefore, this is a function. For G, we have for every x value, okay, 5, 6, 7, 8, it has a correspondent y value, which is 0 and 1. Is this a function or not? Again, this is a function. Why? Because the given definition of function would state that for every x or for every input, there should be only one output or one y value. So we have this one. We have 5, 0. That is unique, right? 6, 0, 7, 0, 8, 0. Okay, again. I mean 5, 1. So we have the ordered pair here. I will write this one. 5, 1. Then next we have 6. We have 6, 0, 6, 0. Then 7, 1. Then 8, 0, 8, 0. Then we have the last one, that is 9, 0. So again, we have the x 6, 7, 5, 6, 7, 8. Their corresponding values are unique for every x. So therefore, this is a function. Next, this one is not a function. Why? Because the output of 7 is 11 and 13. So obviously that is not unique. And the output of 2 is 17 and 19. And again, that is not unique. Okay. So next, we have function as a graph in a Cartesian plane. Before we test a graph, if it is a graph of function or not, we need first to discuss what is vertical line test. A vertical line test states that a graph represents a function if and only if each vertical line intersects the graph at most 1, or it will only intersect the graph at 1 point. We have here an example. Which of the following graphs can be graph of functions? So we have letter A, B, C, D, and E. So we will use the vertical line test. Using vertical line test for letter A, graph A, so obviously, it only intersects at 1 point. So therefore, this is a function. This one, again, a function. This one, this is also a function. How about this one? Letter D. Obviously, this is not a function since the vertical line intersects the graph at least at most 2 points. Therefore, not a function. And last one, letter E. This is not a function since it intersects again the graph at most 2 points. Therefore, not a function. Next, we have this one. Since we already done discussing a function or not by ordered pairs, by by mapping, by graph. So this time you have here a practice exercise. Which of the following sets of ordered pairs are functions? We have letter A, letter B, letter C. Again, let number one. Which of the following sets of ordered pairs are functions? Letter A, letter B, letter C. Number two. Which of the following mapping diagrams rather represent function? We have A and B. Which of the following are functions? And number three. Which of the following graphs can be a graph of functions? We have A, B, C, and D. So again, this will be your practice exercise. So that's all. Thank you. Again, have a great day.